Let's do a quick little review of waves themselves and make sure we understand kind of what waves are. So waves are a disturbance that transmits energy. So you can visualize the electron is a disturbance in our world that's actually just transmitting energy versus seen as a particle, okay? You can also just say, just like any wave, a wave of energy has a certain amount of wavelength to it, which means the electrons have a certain wavelength to them also. So when they're acting as a wave, they actually have a very specific wavelength to them, okay? Now, if you want to generate a wave and you want it to stick around, okay, you want it to basically repeat on itself. It's called a standing wave, all right? All of my musicians know this because when you are singing or you are playing an instrument, you are creating standing waves that have a certain note or a certain frequency to them, all right? And as you play your instrument or sing your note, you're going to create that standing wave, okay? Think of like vibrations in a woodwind instrument or a brass instrument, or even better so, like the vibrations on a string of a guitar. That string creates a standing wave. Now, those are all linear. Imagine if that standing wave had to wrap itself around a nucleus which was attracting it. If that was the case, that standing wave, which has to repeat on itself, okay? So if I take my cursor here and I show you that this wave is moving through a wave pattern over and over and over and over and over again, which is great. If I was a little car driving on this, I could follow this pattern forever because this is a standing wave. It repeats on itself. Well, that works in this spherical nature, repeating pattern. It works here where we get 1, 2, 3, 4 nodes. Here we had 3 nodes. But anywhere in between spatially or energy, it doesn't work. So you have these regions where the wave of energy, the particle, the electron, can't exist because its wave pattern doesn't line up to create a standing wave, okay? So what happens is we get a standing wave at a certain amount of energy, we get another standing wave at a next amount of energy. In between those two things, the standing wave doesn't happen, okay? Now, electrons acting as waves is the reason why we have quantized energy, okay? So if electrons didn't act as waves, we wouldn't have a reason why that electrons behaved in this pattern which we experimentally see with our emission spectrums. So it all kind of comes together that we see emission spectrums, which means electrons have to act in a manner that quantizes their energy, okay? A particle wouldn't need that. If we apply this idea of electrons acting as waves, then it actually aligns because the wave itself can only exist at very specific amounts or very specific quantum of energy. That's where our quantized energy comes from, is because of the wave-like behavior of the electron, okay? I know it's a lot to digest, but this is kind of, some of these things you just kind of have to like, okay, I got it, Mr. Dirksen. Electrons act as waves, and because they act as waves, that is why they can only be at set energy levels. Yes, that is why. Okay, that's the basic answer here. And the reason why that is because waves need to be in a standing wave pattern to repeat on themselves. Okay, so they don't destroy themselves. Okay, if you've done anything with waves before, you know that if you have, waves that repeat on themselves, they have like crests and troughs. And if the crest hits a trough, it kills itself. Same thing happens here. So they only can work if they line up perfectly or have very specific quantized energy to them. All right, so that is how the wave moves. So because of this, we now know the electrons don't orbit in these nice patterns. Instead, they act like waves around the outside of the atom, okay? Which gives them their quantized energy, which then leads us into the quantum model of the atom. All right, we're going to end the video here because I'm not going to take you even down the road even further than what I just did. All right. The next time we get together, we're going to talk about the quantum model and how the things that we talked about from the bridge between the planetary model and that quantum model and what we now really believe the atom looks like. Cool. Thank you.